Good morning, all of you. So last class, we saw the set transform properties. We were reviewing the fundamentals of signals and systems, starting from Laplace transform, Fourier transform, continuous time Fourier transform, and we saw what are the different signals, different systems, etc. All those things we reviewed in the last class, and we were seeing set transform in particular. And in set transform, we are seeing the different properties. Last class, we saw the property of, say, what will be n set transform of nxn, and we saw that it will be minus z dx by dz. Okay. Now, today, last class we used some PowerPoint presentations. Today we will be experimenting with, say, two boards, basically one white board and one green board, which I have arranged here. You can see it here. I shall make sure that it is visible to you. So this is the okay. So I'll try to make use of this whiteboard as well as a green board which we have here. Okay. So last class we saw we derived the property of set transform, which is nxn. We shall just review the other properties of set transform, and we'll do some problems also. Okay, now, okay, coming to the board, you just tell me whether the board is visible to you clearly. I'll keep it such that it is visible to you. What I am writing is visible to you, right? What happened? What happened to him? You should be able to get inside. Ask him to join through the link I have given to him. Anyone can join. I have not restricted anyone. Okay, so now we shall see some properties of set transform. Say x n, if xn has a set transform, say xz, what will be the set transform of, say, xn minus n0? Xn minus n0. So how will you find this? You will put n minus n0 equal to, say, u. Then the set transform of this one is basically sigma x n minus n0 z raised to minus n. Is it clear? Is the board clear to you? Is it okay for you? Just type something. Okay. Okay. Thank you. Thank you. Yeah. Okay. So sigma x n minus n0 z raised to minus n is the set transform of x n minus n0, and if you put n minus n0 as u, n can be replaced as u plus n0. From this equation, n is u plus n0. So substituting this here, you get sigma xn, n minus n0 is u, so you put x of u, and z raised to minus n. What is n? N is u plus n0. So you put u plus n0, and this can be written as sigma xn z raised to, sorry, xu z raised to minus u into z raised to minus n0. And this is a summation of n, say varying from minus to infinity basically, and if you have unilateral set transform from 0 to infinity, and this is variable of now the variable you have changed from n to u, and when n is 0 and n is infinity, you also take the 0 and infinity value. So u varying from 0 to infinity. So this is a summation of u, and z raised to minus n0 doesn't contain u, you can take it outside. So this becomes z raised to minus n0 into sigma xu z raised to minus u. Now what is sigma xu z raised to minus u? Sigma x raised to xu z raised to minus u is basically capital Xz. Okay. So what do you understand from this? Xn has a set transform. Xz, that means xn minus n0 has a set transform. What is the set transform? You have z raised to minus n0 xz, or xz into z raised to minus n0. Is it clear? Is it clear to all of you? You can just type yes or no. Okay. Yeah. Yeah. Thank you. Now we shall see what is the set transform of a signal, a discrete. If you take set transform means you are considering only discrete signals. So let us consider another discrete signal represented like this: 0, okay. This is the signal. This is n. This is the magnitude represented as, okay. This is basically the y-axis. You have, suppose you have a magnitude of 1. Then how can you represent this signal? Say suppose this is x of n. Can you try to write it in terms of u of n? How will you write it in terms of u of n? Can one of you unmute and tell how you write this discrete signal in terms of u of n? Okay, I'll call some names. And Harita, can you tell what is the, how do you represent xn in terms of un? Harita is here. Harita is attending the session. Please type yes or no. Yeah, Harita is there, I think. Can you unmute and tell something? Ashwin is there? Okay, Uddhav is there, no? Uddhav? Uddhav, are you there? Okay, Abhishek have told something. UN minus 4. Very good, Abhishek. Um, see, if I ask someone, it's their responsibility to tell something back. See, this is supposed to be an interactive section, and if I ask something, please respond. Otherwise, it is better to give you some video notes. This kind of interactive sessions are not necessary. Okay, so this Abhishek, thank you. This is UN minus UN minus 4. UN minus 4. So what is UN? UN is a signal like this discrete signal starting from 0 to infinity. And UN minus 4. What is UN minus 4? It is a shifted version of unit step signal starting from 4. So you have a signal UN which starts from 4, and if you subtract UN minus 4 from UN, you get only the signals 0, 1, 2, 3. So Xn can be written as UN minus 4. Okay, now can you try to find the set transform of this? How will you find the set transform of this? Set transform of Xn that is a set transform of UN minus 4. Now applying the property that set transform of A plus B is set transform of A plus set transform of B, this becomes a transform of UN minus 4. Now what is this? A transform of UN? What is a transform of UN? One of you can unmute and tell. See, I want these sessions to be interactive. If this is not interactive, there is no if this is not interactive, it's of no use. We want session to be interactive. That's why we use these interactive platforms. Otherwise, I can give you some PPTs and I can give some video lectures and tell that you can study something like that. Yeah, very good. Vaishak is telling that it is set by set minus 1. Very good, Vaishak. You can unmute and tell also. Okay. This is set by set minus 1 minus set transform of UN minus 4. So how do you find set transform of UN minus 4? This is a shifted version of UN. UN, you know, it is set by set minus 1. So how will you find set transform of UN minus 4? You apply the property that we have already just seen now, that is a set transform of UN minus N0 is z raised to minus N0 xz. So now, can one of you tell what will be the set transform of UN minus 4? You can just unmute and tell, no need to type. Typing may be difficult because you may need to find some mathematical equations and all editor for that.
Z raised to minus 3 by Z minus 1.
Z raised to minus 4 by, Z raised to minus 3 into Z by?
Z minus 1.
Z by Z minus 1. Z raised to minus 4 into Z means it is Z raised to minus 3 itself, correct? By Z minus 1. How do you get it? UN has a set transform Z by Z minus 1. So UN minus 4 will have a set transform Z raised to minus 4 into Z by Z minus 1. So z raised to minus 4 into z means it is z raised to minus 3. So z raised to minus 3 by z minus 1. This you can write as say z minus z raised to minus 3 by z minus 1. Okay. So this is how you find it's a transform of signals. Is it clear to all of you? Can you just type yes or no? Okay. Yeah. Now, can you try to find inverse a transform? What is inverse a transform? What do you mean by inverse a transform? If you are given a set transform, what is the time domain representation of that set transform? Okay. For example, inverse set transform of z by z minus 1 will be, what will be that? Inverse set transform. You can type or you can unmute and tell.
U of n.
U of n, very good. So inverse set transform of z by z minus 1 is U of n. And suppose that you want to find the inverse set transform of, say, 3 by z minus 1 into z minus 2. You are asked to find the inverse set transform of 3 by z minus 1 into z minus 2. How will you proceed? You can first split this into two set transforms. Okay. First, split this into two set transforms, to summation of set transforms. Then you can take individual set transform for this. So this you can write as partial fraction a by z minus 1, a by z minus 1 plus b by z minus 2. And from this you can find what is a and what is b. Okay. So can you try to find? I will give you 2 minutes or 3 minutes for this. You just find and tell what is a and b.
A equal to minus 3, B equal to 3.
Okay. Who is telling it?
Jibin,
Jibin. Okay. A equal to
minus 3,
minus 3, b equal to
3.
3. Very good, Jibin. That's correct answer. And how will you find it? You multiply everything with z minus 1 into z minus 2. So LHS become 3 and this become a into z minus 1. Sorry, this is z minus 2. A into z minus 2 plus b into z minus 1. And from this, you expand this 3 equal to az minus 2a plus bz minus b. Okay. Am I right? Yeah. So z will not be the az. Am I right?
Sir,
Yeah.
put z equal to 1 and minus 1 and 2.
Yeah, you can put z equal to
1.
1. Then what happened? If you put z equal to 1, this disappears. Then you get minus a equal to 3 or a equal to minus 3. Similarly, put z equal to 2, then this disappears and you get b equal to 3. So a is minus 3 and b is 3. So I'll replace a and b with minus 3 and 3. This is minus 3. This is 3. Okay. Now, what is the inverse transform of each of these? How will you find the inverse transform of each of these? Find the inverse transform of each of these. Inverse set transform of the whole thing will be individual inverse set transforms. So this you can write as minus 3 into 1 by z minus 1 plus 3 into 1 by z minus 2. Now what is the inverse transform of 1 by z minus 1? How will you find inverse
U of n minus
u of
n minus 1.
u of n minus 1? Who told that?
Ashwin.
Ashwin, very good. See, 1 by z minus 1 you can write as z inverse into z by z minus 1. Do you agree? 1 by z minus 1 you can represent as z inverse into z by z minus 1. And what is the inverse transform of z by z minus 1? You know it is u of n, right? So when you have z inverse here, it is like a shifted version will be there in the time domain. So it become u of n minus 1. Okay. So inverse transform of this is u of n minus 1. So this you can minus 3 you can take outside. So this become minus 3 into u of n minus 1 plus 3 into 1 by z minus 2. What is the inverse transform of 1 by z minus 2? Can one of you tell? Darshana is there? Darshana is attending the session.
Yes, sir.
Yeah, can you just tell?
Hello. Yes, sir.
Yeah. Can you tell what will be the set transform inverse set transform of 1 by z minus 2? 1 by z minus 2 inverse set transform of this.
Sir, I don't know, sir.
Okay. Can you tell what will be the inverse set transform of z by z minus 2?
Is it RAM?
No, it is not ramp. It is of the form. I'll give you a hint. It is of the form z by z minus a. What is the inverse set transform of z by z
No,
minus a?
sir.
Okay, I think yeah, you can just unmute. I think most of you need some refreshments. These things are we have already seen. You just refresh what we have already seen. Okay. So z by z minus 2. Can anyone else tell? Can unmute and tell?
A raised to n into u of n.
A raised to n into u of n. Who is that telling?
Akin.
Akin, very good. See, this is of the form a raised to n u of n, because z by z a raised to n un has a set transform z by z minus a, and this is of that form. So in its inverse set transform is a raised to n What is a here? It is 2. So you have 2 raised to n, 2 raised to n u of n. This is the inverse transform of z by z minus 2. Now what will be the inverse transform of 1 by z minus 2? 1 by z minus 2 you can write as z inverse into z by z minus 2. 1 by z minus 2 you can write as z inverse into z by z minus 2. Now can you tell what will be the inverse transform of 1 by z minus 2? You can unmute and tell, or you can type. Better you unmute and tell. I can hear your voice, because I feel that sometimes that I am teaching computer. I am teaching students. I have to sometimes get that feeling. You unmute and tell what will be the inverse transform of 1 by z minus 2.
2 raised to n minus 1 u of n minus 1.
2 raised to
N minus 1 into u of n minus 1.
n minus 1 into u of n minus 1. Who told that?
Ashwin.
Oh, Ashwin, very good. See, when you have z by z minus 2, its inverse transform is a raised to n un or 2 raised to n un. But when you have z inverse into z by z minus 2, you have z by z minus 2. 1 by z minus 2 is z inverse into z, that is 1. Z inverse into z by z minus 2. So you have a z inverse into z by z minus 2. Z by z minus 2 has a inverse transform 2 raised to n un, and you have another z inverse multiplication. When you have z inverse multiplication, what does that mean? When you have z inverse, you have a time shifting in time domain. So your n become n minus 1. So all n become n minus 1. So this n will become n minus 1. This n will also become n minus 1. So inverse transform of 1 by z minus 2 is 2 raised to n minus 1 into u n minus 1. Is that clear? 2 raised to n minus 1 into u n minus 1. So coming back, this become 3 into 1 by z. This has a z transform 2 raised to n minus 1 u n minus 1. So this is the basically the inverse transform of the signal. This is normally represented as hz, which is the transfer function in discrete domain. So 3 by z minus 1 into z minus 2 has an inverse transform minus 3 un minus 1 plus 3 into 2 raised to n minus 1 u n minus 1. So this is how you approach finding the inverse transform problems. Is that clear to you? Yes or no? Is that clear to you? Okay. I got only 2 yes. Others doesn't understand. Yeah. Okay. If anybody don't understand, please write no. It doesn't matter. I'll repeat or try to. Anyway, these videos I will upload in YouTube and share you in Moodle. So if you have any doubts, you can review those videos and clarify your doubts. Okay. And you can, you are most welcome to send me some mails regarding the doubts. I can answer that. Is it clear to you? Okay. Now, I'll give you a problem, a numerical. You can try to solve it now. And I'll give 1 or 2 very small assignment which you can do today and upload in Moodle by today midnight, and that will be considered for continuous evaluation also. Okay. Do you like whiteboard or green board? Can you answer? Or both? Whiteboard is comfortable. Okay. Maybe I used a lot whiteboard. Shall I use a green board a little bit? Okay, whiteboard is easier to read. Okay, many of you told whiteboard. So probably I'll use mostly whiteboard. And if I don't have enough space here, I may use green board also occasionally. Okay, all of you wrote it as whiteboard. Coming back. Yeah. You can try to solve this, try to find the inverse set transform. Inverse set transform of z by z minus 2 into z minus 4. You can use the same method. You can write this as a by z minus 2 plus b by z minus 4 and try to answer this. I'll give you 5 minutes. What is the time now? It's yeah, 3. You can utilize 5 minutes for this. Okay. Okay, coming back. So did you get A and B? If you write this as a by z minus 2 plus b by z minus 4, you can type a and the values of a and b in the chat window. Uddhav, a equal to minus 1, b equal to 2. Good. A equal to minus 1, b equal to 2. Neha, okay. Correct. I got 3 correct answers. How do you do this? You multiply everything with z minus 2 into z minus 4. So when you multiply both numerator and denominator, denominator disappears here. So this becomes z equal to a into z minus 4 plus b into z minus 2. Okay. So you put z equal to some, say 4 and say z equal to 2. When you put z equal to 4, this term disappears. And what happened here? This becomes 2b equal to z 2b z. Right. Put z equal to 4. 2b equal to 4. Or b equal to 2. and put z equal to 2, this disappears, and what do you get here? 2 minus 4 is minus 2a equal to 2 or a equal to minus 1. So a equal to minus 1, b equal to 2. So substitute it here. A equal to minus 1, b equal to 2. Okay. Now how will you find the inverse transform of minus 1 by z minus 2 and 2 by z minus 4? Inverse transform of minus z minus 2 plus 2 by z minus 4. What can you tell what will be the inverse transform for this? Again, apply the same method that we have used. This you can write as minus z inverse into z by z minus 2 plus 2 into again z inverse into z by z minus 4. Okay. Now this is minus z inverse. You have z inverse here. Z by z minus 2 has an inverse transform. This of the form z by z minus a. Its inverse transform is a raised to n un. Here it is 2 raised to n un. And you have a z raised to minus 1, which become shift or n become n minus 1. So this become u n minus 1, 2 raised to n minus 1 into u n minus 1. Minus here, minus 1 into this one. Okay. And plus 2 into, similarly here, this is a raised to n un or 4 raised to n un, and you have a z inverse here that become n minus 1. So you have 4 raised to n minus 1 u n minus 1. So this is the inverse transform of z by z minus 2 into z minus 4. Is that clear to you? Is that clear to all of you? Okay. Yes. Yeah, good. Okay, very good. So I'll upload, I'll stop recording now. Okay. Hope you had a good session. Can you just give some feedback regarding today's class where I have used whiteboard and green board? One of you can unmute and tell, or you can tell after unmuting. I want some feedback from you, whether the PPT method or using these white and green boards, which is better. Can you just give me some few words? You can unmute and tell. Board is better than PDF. Whiteboard is better. Mata, yeah. More feedback, yeah. Using board is better than PPT. Yeah, that's what I also feel. PPT and a board madi, okay. More feedbacks, you can write whatever you feel. The session was good using board, feel better. Okay, good. Using board is more engaging, right? Right. And it need to be interactive. If I ask someone, you should not leave the session and go. Okay. Yeah, this was much better than previous session. Easier to understand. Okay. Yeah, this is more effective. Okay. Okay, I think we can conclude the class, and you may need to go to the next session. Yeah. So thank you all of you. We shall see in the next class. We shall continue with the next class. And today I will give some assignments. You can very small assignments. You can do it and upload in Moodle by today midnight. Okay. Thank you all of you. Yeah. Thank you all of you. Thank you. Thank you. Thank you. You can move to the next session. Yeah. Thank you. Thank you.